multiple choice question on limit and continuity of several variables. Consider first example. Find limit xy tends to 0 0 0 0 x square minus y square divided by x minus y. So here if we simplify this is limit xy tends to 0 0 is equal to, the numerator becomes x minus y into x plus y divided by x minus y. This term will get cancelled here. It is equal to limit xy tends to 0 0 x plus y, which is equal to 0 plus 0 is equal to 0. So the answer is what? 0. Second example, find limit xy tends to 0 1 of x plus y minus 1 divided by under root of x plus y minus 1, and the given options are option number A, it is 9, option number B 0, option number C 6, and option number D is equal to 2. So here limit xy tends to 0 0. First we want to simplify this expression as 0 1 x plus y minus 1 divided by under root of x plus y minus 1 into under root of x plus y plus 1. We are going to multiply and divide by x plus y, square root of x plus y plus 1. So we know that this is a minus b into a plus b is equal to a square minus b square. So this is it is equal to limit xy tends to 0 1 x plus y minus 1 into under root of x plus y plus 1. It is equal to, if we take here a minus b, a plus b, it is a square minus b square, so it is x plus y minus b square, that is minus 1 square. So here minus 1 square is 1. This is equal to, now this term will get cancelled here, x plus y minus 1 will get cancelled here, this term will get cancelled here, and it is equal to limit xy tends to 0 1 under root of x plus y plus 1. Now here at the first step we cannot directly put the limit x is equal to 0, y equal to 1. If we put here x is equal to 0, y equal to 1, the denominator becomes infinity. But here you can, if you put x is equal to 0 and y equal to 1, then value is what? Under root of 0 plus 1 plus 1, so it is equal to 2. So answer is what? 2. So here correct option is what? D. Correct option is D. Next example number 3. Which of the following set is bounded? Which of the following set is bounded? And the sets are given. Number 1, A, collection of all xy such that x square plus y square is greater than or equal to 1. Option number B, collection of all xy such that 1 less than or equal to less than x less than 2. Option number C, collection of all xy such that mod of x plus mod of y equal to less than or equal to 1. And option number D, collection of all xy such that mod of x minus mod of y equal to 0. So when we said it is a bounded set, if you determine, when we said a set A is bounded, a set A is said to be bounded if there exists a real number m and capital M such that M less than or equal to x less than or equal to M for every x in set A. Okay, so here the first set A is given x square plus y square is greater than or equal to 1. We know that this is an equation of circle. This is an equation of circle having center 0 0 radius 1, and it contains all the points which are x square plus y square greater than or equal to 1. That is, all the points lie outside the boundary. So again, this set is not bounded. The set A is not bounded. Again, in this set there is a restriction on what is the B. For B, if we draw its set here 1 and 2, but there is no restriction on Y. So Y varies. So here Y is what? Again, there is no restriction on Y. So again, this set is unbounded. Again here, mod of x plus mod of y less than or equal to 1. So number 3, mod of x plus mod of y less than or equal to 1. Mod of x plus mod of y less than or equal to 1. So here we know that if you simplify this expression, we get 4 equation: x plus y less than or equal to 1, x minus y less than or equal to 1, minus x plus y less than or equal to 1, and x minus y less than or equal to 1. So these are the 4 equations, and if we draw its geometrical representation, then the first equation is x plus y less than or equal to 1. So we know that x plus y less than or equal to 1. So this is the equation of line x plus y equal to 1, and all the points which are less than or equal to 1, these are the points which are less than or equal to 1. Then next, x minus y equal to 1, that is when x is 0, y is minus 1, and when y is 1, x minus y less than or equal to 1. So here, if x is 0, if we convert this equation into equality, x is 0, y is minus 1, and y is 0, x is 1. So y is minus 1 and 1 0. So this is what? This is all the points. Okay. Again, similarly, if you draw, this is the third equation, and this is what? The fourth equation. Sorry, fourth equation. So you will get the diagram like this. Okay, this is 1 minus 1 1 minus 1. So all these points inside this it like a kite. So this set is what? It is bounded set. And if we consider the last option, number D, what is D? Here D is equal to mod of x minus mod of y, mod of x minus mod of y equal to 0. So there are infinitely many solutions for this equation. The first solution, you can say, if you collect the set here, the set A is equal to first 1 1, then 2 2, 3 3, 2.1, 2.1. So all these xy pair xy satisfying this equation, x plus y equal x minus mod of x minus mod of y equal to 0. Or if you solve this will get mod of x is equal to mod of y. That is, this implies it has two solution, x is equal to plus or minus y. So if you draw its geometrical representation, so x is equal to y, this is the equation of x is equal to y, and this is x is equal to minus y. All these points satisfying this equation, x minus all these points on the boundary satisfies this equation, mod of x minus mod of y equal to 0. So again, this set contains infinitely many points. So the correct option is what? C. The correct option is what? Mod of x plus mod of y less than or equal to 1. That is, if you draw the geometrical representation of these 4 equations, you get such a diagram, and it contains the point inside the region. Okay, this is the region satisfying equation mod of x plus mod of y less than or equal to 1. And so we can observe that each of these elements less than or equal to 2 or uh, greater than or equal to -2 or -1. So this set is what? Bounded set. Next, if we consider the next example, find the domain number 2, or maybe next number, find domain of the function f of xy equal to log of mod of x square plus y square, and options are given. What is the domain of this function f of xy, and the options are given. Xy, collection of all xy says that xy belongs to R. Number B, collection of number B is R square minus 0 0 0. Number C, R square, and number C, R square, and number D, it is collection of all xy such that x greater than equal to 0 and y greater than or equal to 0. So from this, now I want to determine the domain of this function. Again, we know that logarithmic function is continuous everywhere, and it is not continuous, or it is not defined if it is, this term is what, less than 0. But again, since x square plus y square is always greater than or equal to 0 for every xy in R square. Okay, so but again, log is not defined for 0. Log on 0 is what? Undefined. So this function is defined everywhere only if x is equal to 0 and y is equal to what? 0. So what is the domain here? Undefined. R square minus 0 0, because x square plus y square is always greater than 0. If it is example is like this, log of mod of under root of x plus y, then in that case this function is defined if x plus y is greater than 0. Okay, x plus y is greater than 0. But here x square plus y square, this term is always positive. So this function is not defined only if x is 0 and y is 0. The next example, third example, which of the following functions is bounded? Which of the following function is what? Bounded. And the examples are given. The options are: number A is 1 divided by x square plus y square, x square y square plus 1. B, x square plus y square divided by x square plus y square, not x square plus y square, it is x square y square. X square y square. Number C, x square plus y square, and number D, log of x square plus y square. So now we want to determine which function is bounded. Again, when we said bounded function, which of the function, if it is upper bound, lower bound, again this function is not bounded, because as x, if you take x xy, it is increasing. Okay, so this is what? It is not bounded. This function is what? Not bounded. Similarly, this function is also not bounded. You cannot find x and positive and upper and lower bound for this function, so it is not bounded. Again you can observe here as here xy tends to 0 0 here. As xy tends to 0 0, this function is increasing. This function is 1 divided by x square. That is, suppose here if you take the point, say here f of xy is equal to 1 divided by x square y square plus 1, and if you take the point, say f of 0.0001 and 0.0001, so it is very large value, 1 divided by 0.00000000 times 1, and again it's very large value. So again this function is not bounded, and the last one is x square plus y square divided by x square plus y square divided by x square y square. Now as we know that x square y square is always greater than or equal to x square plus y square. Okay, greater than or equal to, and therefore x square plus y square divided by, or in other words, if you write here, say here in x square plus y square less than or equal to x square y square. Okay, that is, here if you take x is equal to 2 and y is equal to 3, then x square is what, 4, and y square is 9. So this is what, less than or equal to x square y square is 4 into 9. So this is what, 9 plus 4 is 13, is less than or equal to 36. So this is always x square plus y square is less than or equal to x square plus y square, x square into y square. So x square plus y square divided by x square y square is less than or equal to 1, and therefore this function is what, bounded function. This function is bounded function. So what is the correct option? Option number B. Option number B is the correct option. The next question, question number 4. Then it's very lengthy question. Next. Next question is f of xy equal to x raised to 4 y raised to 4 divided by x square plus y raised to 4 raised to 3 if xy is not equal to 0 0 and equal to 0 if xy equal to 0 0. So, and options are given. The first option is limit xy tends to 0 0 f of xy equal to 0, f of xy equal to 0. The option number B, limit xy tends to 0 0 f of xy exists along the path y equal to y square equal to mx. Number C, the limit xy tends to 0 0 f of xy exists but not equal to 0, and number D, limit xy tends to 0 0 f of xy does not exist. So here now we are going to check which one is the correct option. So f of xy is equal to the given f of xy equal to x raised to 4 y raised to 4 divided by x square plus y raised to 4 raised to cube. Now if you take the path along the, say, y equal to y square is equal to mx, say y square equal to mx, then this become limit x tends to 0, so y square is equal to mx. So here it is what, x raised to 4, and it is equal to mx m square x square divided by here x square plus m square x square raised to what 3. So if we take x square outside and if we cancel it, it is what, limit x tends to 0, this is x raised to 6 m square divided by x raised to 6 1 plus m square raised to 3. This will get cancelled here and it is m square divided by 1 plus m square raised to 3, and here limit depends on value of m, and therefore this limit does not exist. This limit what does not exist. So what is the correct option? Option number D. Now take one more example. Next, check whether limit xy tends to 0 0 x plus y divided by x minus y. Find this limit and want to check whether this limit exists or not. Now here if you find the repeated limit x tends to 0, limit y tends to 0, x plus y divided by x minus y, it is equal to limit x tends to 0, x divided by x, which is equal to 1, and limit y tends to 0, limit x tends to 0, x plus y divided by x minus y is equal to limit here x tends to 0 implies limit y tends to 0, y divided by minus y, which is equal to what, minus 1. Now both the repeated limit exist, but they are not equal, and therefore this limit is what, does not exist. Now take one more example. The next example, limit xy tends to 0 0 x minus a divided by y minus b along the path y is equal to 0 is, and the options are given. The first option number A, is 0, option number B is a by b, option number C is minus a by b, and number D, none of these. So we want to determine the limit along y is equal to 0. Here the function is given, limit xy tends to 0 0 x minus a divided by y minus b, and path is given y is equal to 0. As path given y equal to 0, this implies it is equal to, this limit become limit x tends to 0, as y is 0, it is x minus a divided by minus b. So as if we put x is equal to 0, it is equal to minus a divided by minus b. So the answer is what, a by b. The correct option is what, option number B. Now if we take the next example, find the limit xy tends to 0 0, limit xy tends to 0 0 x minus 1 divided by y minus 1 along the path y equal to twice x, is the option number A 0, option number B 1 by 2, option number C minus 1 by 2, and option number D, none of these. So here the given limit is limit xy tends to 0 0 x minus 1 divided by y minus 1, and the path is given y equal to twice x. So along this path, this limit become limit x tends to 0 x minus 1 divided by twice x minus 1. So this is equal to limit x tends to 0 x minus 1 divided by this is what, twice x minus 1. twice x minus 1. Okay, and so if you put here x is equal to 0, this is 0 minus 1 divided by 0 minus 1, so answer is what? 1. And there is no correct option here. Y equal to twice x minus 1, x minus 1. So as x tends to 0, okay, so the correct option is what? 1, and is not given, so answer is what? None of this. None of this. The next example, find the limit x tends to 0, limit x tends to 0 and limit y tends to 0, limit x tends to 0 and limit x tends to 0 of x square minus y square divided by x square plus y square. Maybe this is y tends to 0. So what is the correct option here? The options are given: a is equal to 0, b is equal to 1, c is equal to minus 1 and d is equal to none of these. So here if we put y equal to 0, this become limit x tends to 0, x square divided by x square, which is equal to 1. So the correct option is what? 1. As y first if we put y equal to 0, then what is left here? It is only x square divided by x square, which is equal to what? 1. Now the next example. Next example, limit xy tends to 0, 0, xy tends to 0, 0, xy square divided by x square plus y6 along the path y is equal to y cube is equal to x is, and the options are given. The given options are a is equal to 0, b is equal to 1, c is equal to 1 by 2 and d is equal to none. So if we put here, now if we want to find this limit along the path y cube is equal to x, so this limit xy tends to 0, 0, xy cube divided by xy square divided by x square plus y6 becomes a limit x tends to 0. As we put y cube is equal to x, so here it is y cube, not x, make it correct, y cube. So this is equal to x square divided by x square plus here x square. Okay, so this is equal to x square plus x square, it is equal to 1 by 2. So the correct option is what? 1 by 2. The correct option is what? 1 by 2. Make it correction: x square xy cube divided by x square plus y raised to 6. Now the next example. The next example is limit xy tends to 0, 0, xy tends to 0, 0, xy divided by x square plus y square along the x-axis, is equal to what? Okay, and the options are given: a is equal to 0, b is equal to 1, c is equal to minus 1 and d is equal to none of these. So we want to determine limit along the x-axis. Now along the x-axis y is 0, so if you put here y is equal to, if you take the limit y is equal to 0 here, this limit becomes limit xy tends to 0, 0, xy divided by x square plus y square. If you take the limit along y is equal to 0, this become limit x tends to 0, 0 divided by x square, which is equal to what? 0. So the correct option is what? A, 0. Now next, find the limit x tends to 0, the limit xy tends to 0 0 to 0 0, xy raised to 4 divided by x square plus y raised to 8 along the path y raised to 4 is equal to x, and the correct options are given. A is equal to 1 by 2, B is equal to 2, C is equal to 1, and D is equal to none of these. So here if we put y raised to 4 is equal to x, we get this limit become limit x tends to 0. Since we take the limit along the y raised to 4 is equal to x, so this is limit x tends to 0, x into x divided by x square plus x square. So this is x square divided by x square plus x square, and which is equal to what? X square divided by twice x square, and it is equal to what? 1 by 2. So the correct option is what? 1 by 2. Next, last one. If repeated limit exists, if the repeated limit exists and equal, then simultaneous limit and the correct option is given number A. The options are given, sorry. A is does not exist. Number B, exist. Number C, may or may not exist. May or may not exist. And number D, none of these. So we know that if the repeated limit exists and not equal, if they are, then simultaneous limit does not exist. But they are equal, in that case simultaneous limit may or may not exist. So the correct option is what? C. For example, if you take the simple example here x plus y, x minus y, and limit xy tends to 0 0. Here both the repeated limit exist, but they are not equal. First 1 minus 1, first repeated limit is 1 and other one is minus 1, so this simultaneous limit does not exist if they are not equal. But here if we take the limit x square plus y square, limit xy tends to 0 0, both the repeated limit exist and they are equal to what? 0 0, but simultaneous limit does not exist. So it is not guaranteed that if the repeated limit exists and equal, the simultaneous limit exists. So it may be exist or may not exist. So the correct option is what? C.